between the upper and lower layers of the firmament. And there's a lot of Bible scripture that actually supports that.
Well,
Furthermore,
you haven't pointed to a Bible scripture yet. You just said Isaiah. I don't know where in Isaiah you're talking about.
okay, well, I'll pull up the scriptures, but let me also say that there have been several universities. In fact, the University of Colorado was the first university to discover this, but they have found what they call an impenetrable crystalline type of object. They're calling it like a Star Trek shield that's at an elevation of 7,200 miles above the Earth. Now, the University of Colorado is not the only university that has found this. There have been 2 or 3 other universities that have confirmed these findings, and they are hypothesizing that it is this structure, this impenetrable shield, that is protecting us from the radiation, the lethal radiation of the Van Allen belts, and many other things that would be coming in. So
yeah, I'm aware of that, but that's not the firmament that the Bible's talking about. What you're talking about is a magnetic field that's created by the magnetic poles of the Earth to protect us from any kind of cosmic radiation. In chapter 1, it says that the birds fly in the firmament, not below or above the firmament. They fly in the firmament. So it's a substance, that is the air that we see the birds fly in, that is the firmament.
okay, but no.
So how could it be a dome?
Well, it's nobody's saying. I don't know which video of mine you were watching when you say there was a physical dome. Usually, when I'm talking about a dome, I'm talking about either a magnetic flux that's holding everybody to Earth. I've heard people talk about a crystalline structure. I know Ptolemy and others address that, but it's not something that I've ever stated as it's a fact, or I know it's there, because I don't know. What I do know is it appears that the stars operate on a half hemisphere or a half dome sky, and if you even said it earlier that we can see half the stars at night above the horizon and half below. That tells me we couldn't possibly be on any kind of a ball, because if you take a piece of paper and lay it on your globe, that's going to be your plane of reference. So how are you seeing things anyway? How can you see half the stars? You wouldn't even be able to see half of them. You should only be able to see what's from your horizon and up, which on a flat Earth is exactly what we see.
All right. Well, let me deal with that, because I think we've just hit a very important issue on the difference between my view and your view.
Okay.
The fact is that those in the southern hemisphere see a whole different set of stars throughout the night than we do in the northern hemisphere. We have the Big Dipper is our constellation. We have the Little Dipper. We have the Great Bear. We have Cassiopeia. We have all kinds of constellations. But they don't have any of those constellations down in the southern hemisphere. They have constellations like Octans and Chameleon and Hydrus that we can't see in the northern hemisphere. Okay?
Right.
But if you have a flat Earth,
okay,
then you should be able to see all those stars. The ones that we see in the northern hemisphere and the southern hemisphere of a spherical model.
Well, when they're 25 trillion miles away, you certainly would see them all. But if they are only 3,000 miles up, well, from me in North America to somebody in South America is a lot further than 3,000 miles away. So it would make sense to me that just because I can see a star above my head in North America, that they might not be able to see that star from 5, 6, 7,000 miles away from me. That it makes plenty of sense. Granted, if you take the numbers that we've been given...
Why would that make sense? It doesn't make sense to me. If those stars are 3,000 miles above the Earth and we're all on a flat plane, why shouldn't someone on the right side of that plane be able to see the same stars as someone from the left side? Granted, he may see them from a different angle, but he's still going to be able to see the same stars because they're all above him.
Well, I guess I would have to almost feel like drawing something. If you picture that person, picture a pizza crust, a pizza pie, and the person at the crust or near the crust may not be able to see something that's only 3,000 miles high, but 8,000 miles away from them. You wouldn't be able to see that. Whereas if the person
Why not?
is
Wait. You're jumping to conclusions here. Why would he not be able to see a star 8,000 miles away and only see one 3,000 miles away?
Well, I would have to know exactly what the substance is, or what are the stars attached to, or what are they in. If it's magnetics, if it's
How bright they are.
How bright they are. There's a lot of different things that would go into that.
Yeah, but see, this is
But they don't see
speculation.
them. Well, but what we're saying is to say that they are 25 trillion miles away or more is also speculation. In fact, if you look up the distance of any star, they don't give you an exact value. There's even stars I've seen that say, oh, this star is 500 light years away, plus or minus 300. The fact that they'll say that and then tell us they know everything else is a joke.
Right. No, it's not a joke, because they can only use parallax to 300 light years. So if it's 500 light years away, they're going to have a plus or minus there. That's only logical sense. But I still can't understand why someone who can see a star that's 3,000 miles away can't see one that's 8,000 miles away. Because there's a dark sky. There are stars all around, and 3,000 to 8,000 is not a long distance when you're talking about something that big.
Yeah, but that's like saying that you can't see, why can't you see a flashlight when you can see a big search floodlight? I mean, again, it depends entirely on the.
All right, well, let's put it this way. Let's say the guy that's on that pizza crust uses a telescope. Is he going to be able to see Hydrus and Octans and Chameleon, which are the constellations that we in the spherical model say can only be seen in the southern hemisphere? Will he be able to see them with a telescope in your model?
Yes. Why would you're talking about somebody on the crust is in the south?
Somebody on the crust is in the south.
So
anywhere on the crust?
Correct. So the way that the flat Earth works is there's a middle point, which is the North Pole. Okay? And then anywhere you are on the pizza, if you're facing the middle of the pizza, you're facing north, and behind you is south. It's the same way the directions work on a globe. If you took off from the North Pole walking south, which would be any direction away from the North Pole, if you're at the North Pole and you start walking, you're going south. Keep walking straight, you're going to hit Antarctica, which is the exact same as on a globe. Right? If you're at the North Pole, no matter where you walk, if you walk in a straight line, you'll hit Antarctica, correct? So it's the same thing. You see what I'm saying?
Yeah, I see what you're saying. I'm trying to contemplate it, and I don't.
I should have had some drawings done, but.
Well, I've seen your drawings, and I understand what you're trying to say. But see, the problem is if the guy on the crust can see a star 3,000 miles away, and he can use a telescope to see a star 8,000 miles away in your flat Earth model, well, that's not what happens in the spherical model. In the spherical model,
he could see a star 8,000 miles away is what I said. I said that the guy on the crust would only be able to see the southern stars. Now, if he tried to take his telescope and turn it into the Earth, then you've got everything that you're looking at that's in the way. Dust.
Well, wait a minute. We're talking about pointing toward the sky. We're not talking about putting the telescope on a lateral plane with the Earth, okay?
No.
I'm talking about pointing the telescope in the sky at this star that's 8,000 miles away. Is he going to be able to see that star or not?
No.
With a telescope?
No, the same thing. I can't see the crux from North America. I can't look south and see far enough to see the crux because my stars, picture me standing near the North Pole where North America is, and I'm looking at my sky. Well, to me, the stars are going to start ending, in my view, before I would ever see the outer stretches of those stars.
How do you know that? How do you know that?
Because I can only see the
Let me give you an analogy. Let me give you an analogy.
What I'm saying is that's what I see. It's not how do I know it. That's reality. That's what I see.
All right. Well, let's say we have a circus tent, okay? And the ceiling of the circus tent is analogous to the sky where all the stars are. So let's say we painted white blotches on the ceiling of that circus tent.
Okay.
So now I'm on the ground of that circus tent, and I go to one side of the circus tent, to the edge, and am I going to be able to see all those blotches of paint that I put on the ceiling?
Is the circus tent 25,000 miles across?
Well, okay, let's say I can't see it because my eyesight is bad, so I use a telescope to look at the farthest side of the ceiling tent. Am I going to be able to see it with a telescope?
You will be able to see stars that I see, just like it works. You kind of described it as if we both see southern people only see southern stars, northern people only see northern stars. Where there is crossover, 23 degrees south of the equator can see all the way to the North Star, just like 23 degrees north of the equator can see all the way to the South Star.
Yeah, so I know that, but see, if you have you have this arc of stars that's over your flat Earth, correct? It's like an arc. Is that correct?
Correct. It would be like yes, that's the way they appear, like a hemisphere dome.
Okay, right? So the stars are inside that dome in your flat Earth model.
Maybe on it.
And so why would I not be able to see all the stars if they're all above if they're all above me because I'm on a flat plane?
Okay, so imagine that the tent that you described has stars almost to the bottom of it. Obviously, they're not going to go all the way to the ground, but they're going to be at a place where if you're standing in the middle of that tent, you might be able to see from the topmost star down to a certain level, and the person who's standing at the crust or the outer edges of the tent, they might not even be able to see the star that's at the middle.
Why not? What's obstructing their view?
Well,
what I'm saying is
I want to say something.
Yeah.
So one of the
that's what we see.
So I mean, there's a lot of dynamics involved. Just because we're saying the Earth is flat doesn't mean you can see Mount Everest from North America, because we have atmosphere, we have perspective, which perspective is a huge thing that blocks our vision from seeing things.
Absolutely.
I mean, just because I have a telescope, and even though if I live on a sphere, I can't see an airplane that is flying over top of Minnesota. So
yeah,
I
agree with all that, but we're not talking about a lateral viewpoint here. We're talking about pointing my telescope up to the sky, where there is no smog, there is no fog.
We do that, and this is what we see.
But still, when we're talking about stars, so I'm assuming we're talking about stars on.
The mainstream.
I'm kind of lost. So we're talking about stars that are all on, like, supposedly the same side, and then there's the other side. Where are these stars all located?
All of your stars have to be above the flat plane. Every one of them. There can be no below the flat plane.
Correct.
So if that's the case, and I point my telescope up, I should be able to see all the stars. Now, maybe Jaron is correct.
No.
Maybe there might be one on the edge, like the bottom edge, that I might not be able to see. Okay, great. All right. But let's say the ones on the far side of the tent, away from my telescope, I'm going to be able to see them because I don't have any obstructions.
So now you're saying that you can see stars when the sun is shining in the sky.
No.
Because the sun is shining in the other side of the world.
We're forgetting that what I'm trying to say is when he says perspective, your vision runs out. So what I was saying is
what do you mean my vision runs out? What does that mean?
Well, go stand anywhere and look out anywhere, and your vision will end. Look at a pair of railroad tracks, and they will appear to come together.
Yes, but if you have a telescope, they won't appear together, you see.
That's not true. It will at the end of the telescope view.
Yes, the telescope also has a finite area that it can see. It is subject to the very same laws of perspective that our eyes are. Just because it has better light gathering capabilities and it has higher magnification does not mean that that it will be able to see infinitely.
If there's something strange in your neighborhood, who you gonna call?